Hello and welcome. We are glad you have joined us. My name is Amit New. I'm a Microsoft technical trainer specializing in security and AI. I am here to walk you through the AZ-305 course, Design Infrastructure Solutions. In this session, we will cover design for non-relational data storage solutions. Where should our data live? And how do we design it to stay available, secure, and resilient? In this module, we design non-relational data storage solutions using Azure storage accounts, blobs, files, and disks, focusing on redundancy, security, and the right choice for each workload. So let's get started. We start with design for data storage. First of all, it is important to understand what data types are we working with. Let's classify our data. We can work with structured data, relational tables with a shared schema, like SQL. We can work with semi-structured data, if we have a structure but not in relational tables, like JSON, XML, YAML files, events, templates. We might have unstructured data, the drop anything scenario like docs, images, videos, PDFs, backups, like OneDrive. In real projects, the best storage is the one that matches the requirement and doesn't surprise you later. For today's module, we are especially interested in semi-structured and unstructured data. Now that we know the data types, we need the management service, designed for Azure storage accounts. Storage account is the management umbrella to consume multiple data storage types. We would like to consider the account type. This is the performance tier. Do we need standard or premium? Do we have any data residency requirement? Storage accounts are regionally deployed. Where do we want to keep our data? Consider regulatory compliance. What standards do we need to accommodate? Are we under a strict budget? Understand what we pay for, capacity as well as transactions and traffic. Access tiers will help us with that. Redundancy. Can we keep on working when something goes wrong? How do we manage this storage? Centralized approach, decentralized approach? I've seen one storage account for everything turns into nobody knows who owns what. So boundaries matter. Data protection is crucial to assure business continuity. What about access? How do we get access to our data? On which conditions? Consider Entra-ID authentication. What about availability metrics? Consider the SLA and durability. Whenever we are deploying a storage account, we first must choose the storage account type. That has a direct impact on performance. Standard storage is backed up on HDD disks. Premium storage is backed up on SSD disks. When we choose standard general purpose V2 storage account, we get in one solution all the data types available for us, from files, blobs, queues, tables, data lakes, and even static web pages. That is suitable for most applications whenever we need backup or shared content in one managed service. If we choose premium storage, we must commit and choose one storage type. We can choose between premium blobs and premium file shares. You can choose premium block blobs to provide latency-sensitive object access. You can count on premium files for your VDI deployments, enterprise file shares, whenever we have IOP-intensive shared storage. We can also consume premium page blobs. Those are great to bring your own custom VHD files to deploy your virtual machines. Choosing the right storage account type avoids two common pains: unexpected throttling and unexpected costs. Take a few moments to think about your organization's storage account. Are these storage accounts already in place? Would you make any changes? What type of storage accounts will you need and why? Let's think about it. Location. For performance and for user experience, we want to keep the storage as closer as possible to the end users or to the services that consumes it. From compliance or data residency perspective, we need to consider our audit needs, retention rules. These often force region choices. From cost perspective, the account type and the tier influence the price. Don't forget about transaction and egress. Storage replication is great for lower cost backup and protection from failures. What about administration? If we have more accounts, it is more isolated, but it also requires more governance. And of course, security and data sensitivity. Think of access, permissions, and encryption. Now, the resiliency question. What happens when something fails? Because something will. Design for data redundancy, because it just gives sense to back up your backup. We can choose from multiple replications option. In Azure, every piece of data is replicated 3 times. In storage accounts, you can choose how. We can choose to work in one primary region and keep 3 copies of our data within the same region. That will help us get protection from internal data center failures. We can also consume it on top of availability zones, meaning each copy is isolated to its own zone, independent from cooling, power, and networking. That means that even if we have a data center that is failing or a zonal failure, we can still keep on working. To provide higher redundancy and very much useful for lower cost backup, we can provide geo-redundancy. That means that we will keep 3 copies in our primary region and 3 other copies in a secondary remote region. We will rely on the Azure region pairs. Those are designed to have high availability, making sure that if one goes down, the other one will not be impacted. For example, if something is impacting central US, it's not likely to impact East US. When using geo-redundancy, we get protection from complete regional failures. There is an asynchronous mode for the replication to assure that if something is corrupted in my primary region, my secondary region will not be corrupted immediately. If we would like to query the point in time of the synchronization, the delay, and the data that we might lose if we fail over, we can enable read access to the secondary region. This is also great for traffic distribution. If I have my Western European users, I can provide them with my primary region that is in the West Europe. And for my Northern Europe users, I can provide the secondary endpoint in North Europe. I can leverage load balancing solution for proper traffic distribution. The most redundant option that we can have is GeoZone redundant storage. That means that we keep in the primary region on top of availability zones, and we replicate into 3 other copies in the secondary region. For that as well, we can enable the read access for the secondary region. That means that all of the endpoints will be visible for us, both from the primary and the secondary region. We can easily validate what data is being transferred to the secondary region and fail over if something goes wrong. That will help us get protection from internal data center failures, complete zonal or data center failure, regional failure as well. When we are working with locally redundant storage, we get durability of 11 nines. When we are working in zone redundant storage, it increases to 12 nines. Working with geo-redundant storage with read access or not provide us 16 nines, as well as GeoZone redundant storage. Let's explore design for Azure blob storage. Blob storage is the storage that you can drop anything into, extremely common, extremely flexible. Blob storage is an object store for massive unstructured data. It comes with few access tiers that will help us manage cost better. We can consider the online tiers versus the offline tier. Hot, cool, and cold are all online and allowing us to manage cost based on the access that we have to our data. Hot tier is optimized for frequent access. We get lower cost for access and higher cost for capacity. On the cool tier, this is optimization for infrequent access. It requires a minimum retention of 30 days. The cold tier is suitable for rarely accessed data with a minimum retention time of 90 days. We can also consume archive storage. This is an offline tier, meaning rehydration is required. We can keep it in a very low price for a long time retention, but if we would like to retrieve it back, it will take some time, up to 15 hours. We can perform urgent operation and then we can retrieve it up to 1 hour. The minimum retention time is 180 days. Keep in mind this is a very cheap option to keep data that is only needed for compliance reasons. So, when should we choose what? We will choose the hot tier for active app content for ingest and processing, as well as staging. The cool or cold tier are perfect when we have, for example, large datasets waiting for processing. The archive tier should be used for compliance, long-term retention, for data that is rarely accessed. It is like putting a box in a warehouse. It is cheap rent, but you need to travel all across town to get to your data. Keep in mind there are early deletion penalties whenever we change the tiers. Cool, cold, and archive have a minimum time retention. If you move or delete one of them before that window, Azure can charge you early deletion fee. That's why lifecycle management rules matter. So what are they? What are the lifecycle management rules? We can automate the tier transition using the lifecycle management rules. For example, we can start working on the hot tier. After 30 days that the data hasn't been accessed, move it into the cool tier. After 90 days, move it into the cold tier, and after 1 year, archive it. Immutability is about temper resistance. If we must prove that data wasn't modified or deleted, immutability is your friend. It supports warm state, write once, read many. Very suitable for audit or investigation. Finance, healthcare, broker-dealer style compliance, but honestly, any organization protecting critical evidence can use it. For example, we know that we have ongoing audit and we need to keep our data the same for the next 3 months. We can place it under a time-based retention. But maybe we're under investigation and we have no idea for how long. We can place it under a legal hold by identifying tag, assuring all data is kept without changes or deletions. When we need shared folders, lift and shift file servers, NAS-like behaviors. Azure File is the natural conversation, so let's design for Azure Files. When would we choose Azure Files instead of blobs? We can use it when we need SMB semantics, shared access, or mounting it as a drive or an AVM or a server. It supports hybrid patterns with Azure File Sync. It's very useful to configure persistent storage for unpersistent environments like VDI or AKS. File shares support SMB, REST interface, and NFS 4.1 protocols. It is best when we need better IOPS per volume. Azure blobs are great for analytical data at scale, throughput-heavy workloads for backup, archive, and massive amount of unstructured data. We can consume blobs through the REST interface, NFS 3.0, and we can also build on top of it data lakes. So, if you're streaming a video, blobs feel natural. If you're mounting a shared drive, files is the obvious answer. Azure NetApp Files is for when you need enterprise-class NAS performance and you don't want to reinvent storage tuning yourself. It is perfect for high-performance computing, for VDI, AVS, SAP on Azure, workloads that care deeply about I/O behavior. Let's see an example. We can consume hybrid file shares with Azure File Sync. That actually provides us a great way to centralize storage and allow synchronization between multiple servers. You can configure a path on each of the connected servers through File Sync. They will keep synchronization between them and upload the data into the Azure file share. So it will be accessible both from the servers but also through the REST interface from the cloud. It is also supported for Azure Backup and Site Recovery. Now, we switch from shared object storage to block storage for compute disks. When working with Azure disks, we want to consider the type of disk. Do we need HD, SSD, Premium SSD, Ultra SSD? We can consider local caching. Of course, security. We can consider encryption for BitLocker or DMCrypt. We also want to consider our data protection with operational backup. We always recommend using managed disks. Azure handles the replication and availability behind the scenes. We can use Azure Disk Caching to optimize read-write patterns when appropriate. Data protection is important, so consider the encryption options. We can use the storage service encryption on the server side. We can also consume a more holistic approach for encryption with Azure Disk Encryption or encryption at host. That will help us protect our OS disk, data disk, the caches, temp storage, and the flows between the VM and the storage. If we need more performance, we can combine multiple disks, scale out the IOPS. Some of them can even be shared across virtual machines or clustered scenarios. We want to match the disk tier to the workloads, avoid overspending, and avoid bottlenecks. Considering proper security controls is a critical step in our architecture. So let's design for storage security. Consider identity and access. How do we authenticate and prove who we are? How do we authorize requests and make sure that we can do exactly what is needed? For best practice, we will use Entra-ID authentication and granular role-based access control. For authorization, we can also use access keys and shared access signature, but those are powerful. Treat them like radioactive material. Only when needed, store them safely, rotate frequently. Consider where traffic is coming from and apply network controls. We have the built-in firewall and networking rules to allow us to consume private traffic from our virtual networks through service endpoints, or even isolate every single endpoint into a private endpoint with the private link services. Time to review what we learned. All right, let's put our knowledge into test and see how well we know the Azure storage features that will help us build great solutions. We will read the question. You can pause the video for as long as you need. Then, by clicking on the flip cards, we will reveal the answer. Let's get started. First up, which redundancy options are available for Azure Storage Account that allow read access to the secondary region? Ready to reveal? There we go. Read access geo-redundant storage and read access for geo-zone redundant storage. Both are the options that are available for us. All right, second card, second feature. Which Azure blob access method allows providing access for a specific time span? Ready? There we go. This is shared access signature. This time we have a choice between 5 answers. So, which of these is not a security feature of Azure Storage? Is it shared access signature, Azure Active Directory or Entra integration, encryption at rest, transaction optimized tier, or encryption in transit? Ready? Let's find out. Transaction optimized tier is not a security feature. It is a great feature, but not related to security. Next up, which performance tier in storage account is suited for hosting data for a mission-critical application? Do you have an answer in mind? Let's reveal it. The premium performance tier. Next, which protocols are supported by Azure File Share? Ready? Let's see. SMB and NFS. Last one. What are the different access tiers available for Azure Blob Storage? Ready? All right, let's review. We have hot, cool, cold, and archive. Well done. Now we can keep designing storage with confidence. Let's go back to the presentation. Let's explore a use case. Tailwind wants to reduce storage costs by reducing duplicate content and, whenever applicable, migrating it into the cloud. They would like a solution that centralized maintenance while still providing worldwide access for customers who peruse media files and marketing literature over their public website. Additionally, they would like to address the storage of the company data files. They have several requirements for different data types. First, we have the media files. Those are product photos and feature videos on the company public website, mostly JPEG and MP4. We don't know what are the access patterns, mostly uneven. During the peak hours, the website pages are slow to render. Another requirement is for the marketing literature. Those are customer stories, sales flyers, size chart, and eco-friendly manufacturing information, mostly PDFs. Internal users access it via a mapped drive. Customers access it via the company public website. Another type of data is the corporate documents. Those are internal documents, some of them very sensitive, mostly Office format like Word or Excel. They are accessed and managed via internally developed web application. They're kept for compliance reasons. Pause and think. What factors will you consider in your design? What type of storage accounts are needed? Will you use blob access tiers? Immutable storage policies? How will the content be securely accessed? Let's explore a simple implementation. First, we have our public website, where customer can access it. The website can access a secure backend storage account. For the media files, we can use blob storage. Those are highly applicable for that scenario. For the marketing files that needs to be accessible both from the web application but also through a mapped drive, we can choose Azure file shares. We will provide a mapped drive for the internal users using their workstation to access directly through SMB to the file share. Now, for our internal application, for the internal users. They can have their own isolated backend storage account that is suitable to hold the corporate files. We can choose blobs since they are providing us the immutable blob storage capability. We will wrap it nicely with Entra ID authentication to assure secure access. In this session, we covered design for Azure data storage, design for Azure storage account, design for data redundancy, for Azure blob storage, design for Azure file shares, for disk solutions, for storage security. This concludes our session. There are many ways you can continue your learning journey. We encourage you to watch another video in this course or search out your next favorite topic at Microsoft Learn at aka.ms/learn. I'm Amit Neo. Happy learning.